Hello everyone, welcome back to ThinkLab by Saurabh. So welcome to lecture 3 of our complete machine learning course. So in the lecture 1 we understood what is the machine learning. We also introduced our complete machine learning pipeline. In the lecture 2 we learned the different types of machine learning. We also discussed about the supervised machine learning, unsupervised machine learning and semi-supervised machine learning as well as reinforcement learning, and we learned the difference between the regressions, classification, clustering and the dimension reductions. So today we are going to take the next important steps. So today we are going to understand the complete machine learning workflow. And this lecture is extremely important because from this point forward, we are going to start thinking like a machine learning practitioner. So we are not going to simply ask which algorithm should I use. Instead of we are going to ask how do I solve the machine learning problem from beginning to end. So let's begin. So before starting the coding, so let's look at our complete workflow. So on the screen you can see this is the complete machine learning workflow, and this workflow will follow throughout this course. But today we are going to focus mainly on the steps that happen before model training. So because beginners often make one major mistake, they download the data set, open the Google Colab, import the scikit-learn, immediately train the model. That's not how professional machine learning works. A large part of machine learning is actually, but understanding and preparing the data, right? That's most important. So today we will focus on that process. So to understand the workflow, we need a real problem. So let's imagine we are going for a real estate company, and the company wants to build the system that can predict the house price. So the company has historical information about houses. So our goal is to given information about a house, we have to predict its selling price. So this is the regression problem. Why? Because the target is numerical value and the price. Now let's define how the problem will work properly. So first thing we have to understand the step 1. So the problem definition. So that is the first step is problem definition. So we need to clearly define what we are trying to predict. So our question is, can we predict the price of a house based on their information characteristics? So next let's identify our variables. So our feature could include house areas, number of bedrooms, number of bathrooms, houses, distance from the cities, number of floors, parking space, and the other relevant informations. So our target variable is a house price. So we can understand the features are the house price, features are the house area, bedroom, bathroom, age, location, and floor and parking. And we will send this feature to machine learning model, and our target is the house price. So this is the important decision. We have to identify our input and output, right? So now the question is, how can we just use this business problem versus ML problem? So now I want to introduce one of the most important concepts. So a business problem and machine learning problem are not always exactly same. So the business problem might be we want to improve our real estate price predictions, price or weak process. But the machine learning problem could be predict the selling price of a house from the historical features. So we need to translate the business requirement into the machine learning problem. And this is the important skill. So a good machine learning practitioner doesn't immediately start the coding. They first understand the business requirement and then convert into the technical problem. And you can see on the screen we are now moving to the data collections, right? So once we have the defined the problems, so we need the data, and this is the second step. So the data collection, so we may collect the data from the CSV file, Excel file, database, API, web application, sensor, company system,
or the public data set. For example, let's imagine that we have a CSV file and that contains the historical house information. So for example, area, bedrooms, age, parking, right? So these are all the historical information. And if we have to in the CSV file, that will be the row and columns. So each row represent a house and each column represent a variable, right? So later I show you how to import the CSV file using the Panda. So later in the later part of the video we will discuss in the next lecture. So after the getting the data, the next step is the data understanding. Step 3 is the data understanding. You can see on the screen data understanding. So we have our data set. Should we immediately train a model? No. First we need to understand the data set. This is called the data understanding. So we want to answer the questions like how many rows are there, how many columns, what are the columns name, what are the data types, and what are there missing value, and there is a duplicate row, right? And what are the minimum and maximum values, and are the suspicious value, and what does each columns actually represent, right? So in a Python, pandas will become our best friend. We will use, we will everywhere use the command like the df head to see the first row here, right? So, and also we will use the df safe, df info. So I will understand the pandas in the upcoming sessions, right? So I just try to give you the some kind of hints, why panda is important. So throughout this course we are going to use the panda again and again. So pandas allow us to work with the structured data. So think of pandas data frame as a table. Row represent the observations, column represent the variable. For example, a row could be the represent one customer, another could be the represent the another customer. Similarly, in the house price data set, one row represent the one house. So this structure makes pandas extremely useful for the machine learning. And the next lecture, so we will start learning pandas in a particular, especially for the machine learning in the upcoming lectures. So after that we are moving to the step 4, right? Step 4 is the data cleaning. That's the most important. So data cleaning, right? So this is the one of the most important steps. So real world data set are the very messy. So let's imagine our house data set contain the areas, bedrooms, bathrooms like none, there is missing value, price is something different, age is different. So you can see if there is missing value is there, or sometimes we need to decide what to do. Should we remove the row? Should we replace the missing value? Should we use as a mean? Or should we use this medium? So this answer depends on the problem and the data. So this why machine learning is not just for about the algorithm. It's also required the data understanding and the decision making, right? Now we are seeing the common data problems. So problem 1 is that is a very important problem is the missing values. Some cells are empty and some cells are duplicate. So the same observation may appear multiple times, right? Or the problems, incorrect data. So numerical columns may accidentally be sorted as a text, right? So we have to identify those things, right? There are also problems like outliers. So some observation may extremely different from majority of data. So all this issue need attention, right? So after the step 4, we are moving to step 5, exploratory data analysis. So after the cleaning, we explore all the data. This is called the exploratory data analysis, or we call the EDA. So the purpose of EDA is not simply to create the beautiful charts. It's a purpose to understand the data. For example, we may ask, does house size affect the price? Does the number of bedroom affect the price? Does the age affect the price? Are these unusual houses? So which features appear to have a strong relationship with target? So we can use the visualizations to investigate these questions. For example, a scatter plot can show the house area versus prices. We might see that as a house area increase, the price generally increase, and that's give us the useful informations. But remember, correlation doesn't automatically mean the causations, right? So this is an important principle. So if you see the extremely, extreme examples of EDA questions, so when we are performing the EDA, I want to you develop a habit for asking the questions like what is the distribution of the target? Are there some kind of extreme value? Are there some missing value? Are the numerical feature is skewed? Are the categorical value is balanced? Which features appear the related to target? And some features highly correlated with each other. Are there suspicious pattern? So this question help us to understand our data set before modeling. After that we are moving to next step 6 is the feature engineering. So now move to the feature engineering. Suppose our data set contains like years or current year. So instead of using this two value independently, we might create a house age, right? So we can use the house age equal to the current year minus year build. So now we can create the new feature. So this is called the feature engineering. Another example we can take, like suppose we have a total rooms and house area. So we can calculate the area per room, right? And depending on the problem, the new feature might be contain some useful information. So feature engineering is the one of the area where the domain knowledge can become extremely valuable. Now we are moving to step 7, train, test and split, right? So we need to divide our data set. Why? Because we want to evaluate our model on unseen data. Suppose we have 10,000 house records and we might be use 80% of training and 20% of testing. So approx 8,000 row for the training, 2,000 row for testing. And this model learn from the training data and then we have to evaluate it using the test data. But there is an important issue. If we repeatedly use the test data to make decisions, the test set is no longer truly independent. So that's why when the model tuning become more advanced, so we often use a separate validations like set or some kind we call the cross validations. So we will just study this carefully. For now, remember this thing. Training data is only for learning, and test data is used for the final evaluations. Right? Now we are moving to step 8 is the pre-processing. So we need to pre-processing. Suppose our features have a different scale. For example, house area is 500 to 5,000 and number of bedrooms is 1 to 6 and income is 20,000 to 5 lakh. So some algorithms can be affected by the difference in scale. So we need feature scaling, we need use of standardizations or we use the normalizations. We may also have a categorical value, some as the location, property type, payment method, So machine learning algorithms generally require numerical representations. So we may need the encoding. For example, one hot encoding. So we will learn all this technique in upcoming lectures, right? Now we are moving to most important is the model selections. After the pre-processing, we will move to the model selections. So only after understanding and preparing the data, so do we move toward the model selection? Our problem is suppose regressions, so we might try the linear regressions, decision tree, random forest and the gradient boostings. Or we can also use the XGBoost. So we don't necessarily choose one algorithm immediately. We may train multiple candidates model and then compare their performance, and this is an important machine learning mindset. So don't ask which algorithm is best. Instead ask which algorithm works best for this problem and data set. Right? Step 10 is the model training. Right? So now we train our model. So conceptually this process will be like training features, training input, machine learning algorithm, learning and train model. For example, scikit-learn. So we have eventually write the model fit X train, Y train. So this tells the model learn from this training feature, and this is corresponding target value. So the model then learn pattern from the training data. So I will show you next in next lecture like what is the model dot fit, why we are going to use this scikit-learn, because this is scikit-learn is the basically sklearn. Scikit-learn is basically the a framework for the machine learning we will later use in the upcoming sessions. Next step is the step 11 is the model evaluation. So after the training we make the predictions. So for example we have to compare our actual price with the predicted price. For regression we can calculate the matrix such as MAE, MAC, RMSC, R squared, right? Suppose the actual price is 50 lakhs and a model predict the 40 lakhs. So there is an error of 2 lakhs. So we cross all the test example, we calculate the appropriate matrix to understand the overall performance. So step 12 is the hyperparameter tuning. So what if our model is not performing well? So we can try to improving it. One approach is the hyperparameter tuning. So different algorithms have a different hyperparameters. For example, a decision tree may have a maximum depth, minimum sample split, or minimum sample leaf, and any other settings. So instead of guessing, we will systematically search the different combinations. So we can use the greedy search CB, randomized search CB, and we will study this later. Step 13 is the final model. After the experimenting, we select the best reasonable approach. We have cleaned the data. We perform our feature engineering. We are also prepare the pre-processing, selected the algorithms, then our tune the model, and finally evaluating the result. And now we created a final model. But remember, we should always be careful about the data leakage. Information from the test set should be accidentally influence the training process. So this is another important concept we will study later. And the step of 14 is the deployment, right? So now we are moving to step 14, and after that we will understand as step 15. So now imagine that our house price model work well. So we don't want to remain inside the Jupyter notebook forever. We want to someone to use it. For example, real estate employees enter the house area, bedrooms, bathrooms, locations, and age, and other information. So our application send this information to machine learning model, and the model returns the predicted house price. So the workflow will be like user web applications, API, and ML model prediction in user. So this is the basic idea in the machine learning deployment. Now we are moving to step 15 is the monitoring. So finally we have to monitoring. Suppose we have deployed our model today. It performed very well. But after 1 year the real estate market changed completely. So house prices change, customer behavior change, economic conditions change. So the data entering our system may become different from the data used in the training. So the model becomes less accurate. So this is why production machine learning required the monitoring. We may monitor prediction quality. We can monitor the input distribution, data drift, system performance, and the business parametrics. So if the performance drops in the significantly, so we may need to train our model. So machine learning becomes continuous cycle: train, deploy, monitor, new data, retrain, and deploy again. So now let's go through our complete roadmap one more time. Step 1, the problem definition. What are we trying to solve? Step 2, data collection. Where does our data come from? Step 3, the data understanding. What does our data set contain? Step 4, data cleaning. Can we trust our data? Step 5, EDA. What pattern exists in our data? Step 6, the feature engineering. Can we predict better representations? Step 7, train, test, split. How do you separate the learning from the evaluations? Step 8, pre-processing. How do we prepare the data from our algorithms? Step 9, model selections. Which algorithms should we try? Step 10, model training. Can we train the learn useful pattern?
Step 11, model evaluation. How well does it perform? Right? After that, step 12, hyperparameter tuning. Can we improve it? Step 13, final model. Which approach will we use? Step 14, deployment. Can real user use our model? Step 15, monitoring. Does the model continue to work well? Right? So now I want to remember one important principle. Machine learning is not just for model building. It's a complete problem solving process. Many beginner thinks machine learning equal to algorithms, but that is not correct. So a better way to think about the machine learning is real world problems. Then we take the data, understand the data, then we do the pre-processing on data, and finally we use the model. After that we perform the evaluation of model, then we go with the improvement, and then we have to move to deployment, and then we have to perform the continuous monitoring. So the algorithm is only one part of the entire journey, right? So let's imagine we have a customer data set. So businesses ask, can we predict whether a customer will leave our company? So let's apply our workflow. First we define the problem definitions. So this is a classification problem. Second, we perform the data collections. So we collect the customer information. Third is the data understanding. We inspect the data and columns and data types. Fourth is the data cleaning. We handle the missing value in the incorrect value. Step fifth is the EDA. So we must perform the investigation customer behavior. Sixth is the feature engineering. We create the useful features. Seventh is a train test split. So we divide the data. 8 is the pre-processing. So we encode the categorical feature and scale the where they appropriate, right? Ninth is the model selection. So we might write the logistic regression random forest SVM and other suitable model. 10th is the training, right? So we train our model. 11th is evaluate the model. So we calculate the classification matrix. 12 is the training. We improve the model. 13 is the final model. We select the final approach, and 14 is the deployment. So we integrate into the particular applications, and the 15 is the monitoring. So we monitor the model after the deployment. So that is the machine learning in practice. So what you should learn from the today. So by end of this video, by end of this lectures, so you understand one very important idea. Machine learning is just a process. Is to start with the problem, then we collect the data, then we should understand the data, then we clean the data, explore the data, we engineering the features, we split the data, we just pre-process it, then we select the model, then we train our model, then we perform the evaluation on model, tune the model, and finalize the model, and finally deployment, and we have to monitor continuously. So this process is much more important than memorizing the individual algorithms. So in the next lecture, we are going to start with the practical foundation. So we are going to learn the Python for machine learning. So we start with the Python's variables, data types, list, tuple, dictionaries, set, conditions, loops, functions, and the Python concept that you actually need for the machine learning. So we are going to spend a week learning for every features of the Python. So instead of we will only focus on Python, that is useful for the data science and machine learning. After that, we will move to NumPy, then we understand the pandas, and then we understand the data visualizations, and then we perform our first machine learning algorithms. So this was the lecture 3 of machine learning complete course. So today we learned the complete machine learning workflow. Remember these things: problem, data, understand, clean, explore, features, split, pre-process, train, evaluate, tune, deploy, and monitor. So this workflow will stay with us throughout the entire course. So don't try to memorize everything today. Just understand the bigger picture, because in the upcoming lectures we are going to take each steps, and we also go much deeper. So if you enjoying this machine learning series, so subscribe the ThinkLab by Saurabh and follow our complete playlist. Don't skip the lecture, because each lecture will build on the previous one. So thank you for watching. Keep building, keep learning, and keep becoming 1% better every day. So I will see you in the next lecture, lecture for Python for machine learning. So thank you for watching. Happy learning.